All right. Okay. So we have done equilibrium. Basically, we have dealt with क्या हुआ? Huh? We so we are done with equilibrium. Okay, we are done with rotational equilibrium. We are done with translational equilibrium. All right is fine. Okay, now we want to get into something known as dynamics. Okay, मतलब rotational dynamics. मतलब the things are moving. All right. So if the things are moving and the things are rotating, so the good thing about it is we can draw parallel analogies between rotation and translation. Okay, so what that does is that makes our life very simple. So whatever we used to do in translation, the same thing we are going to do in rotation. The structure, the formula, the form, everything is going to be very, very, very similar. All right. So let's see what are the comparisons. First of all, we saw F is equal to m into a. Okay, and which F? Specifically F external. Alright, the internal forces do not contribute to any acceleration. We know that. Okay, so the external force is equal to mass into acceleration. The analogy of that in rotation would be equal to the torque external is equal to I into alpha. Again, the internal torque does not contribute to any angular acceleration. So the external torque is equal to I into alpha. Okay, so what is the analogy? What we use in as mass in translation, the same thing, a similar thing we're going to use in rotation, which is known as the moment of inertia. Today we'll discuss in detail what is moment of inertia. Is that correct? Okay, again. Okay, so we use three equations of motion. What were those? So one was what? V is equal to u plus at. Then we had v square is equal to u square plus 2as. And then what did we have? We had S is equal to ut plus half at square. Okay. If something is in pure rotation, okay, exact same things are going to apply. Okay. What is common among all of these? What is the condition? The acceleration has to be constant. Acceleration has to be constant. So यहाँ पे what we are going to write is we are going to write omega naught is omega naught plus alpha t. Okay. Then we can write omega square is equal to omega naught square plus 2 alpha into, and this we are going to call delta theta, that is the angular displacement. And then we are going to have what? S का क्या होगा? Theta. Theta is equal to omega naught t plus half alpha t square. Is that correct? ठीक है. यही नहीं, there are more analogies, ठीक है, which we are going to talk about a little later. ठीक है. But dynamics के लिए we need these things. Is that clear? Okay. Can I rub this off? Most of the things you know already. Okay, so now let's deal with moment of inertia in detail. Okay, let's talk about moment of inertia. Okay, so moment of inertia, in the last class we touched upon it. Okay, so what does inertia mean? Inertia means accelerating something is difficult. Okay, so if we talk about in rotational terms, rotating something would be more difficult if it has more inertia. Okay, or it has more moment of inertia. Is that correct? Okay, so moment of inertia is defined again for an axis. So if ever I tell you find out the moment of inertia, you're going to ask one basic question. And what is that? About which axis? So you are going to act about which axis? Okay, so moment of inertia is defined for an object or a group of bodies, but it is defined about an axis. For different axes, for the same object, you can have different moment of inertia. Is that correct? Okay. So moment of inertia for a system of particles for discrete mass distribution, I think we are now comfortable with discrete mass distribution and continuous mass distribution. We have seen that. Okay. So for discrete mass distribution, the moment of inertia is defined as the summation of mi ri square. What is mi? Mi is the mass of that particle. And what is ri? What is ri? Not any distance, the perpendicular distance from the axis. Okay, ri is the perpendicular distance from an axis. Okay, so suppose this is the axis and I have a particle here m1, I have a particle here m2, I have a particle here m3. Alright, so what would be r1, r2, r3? R1, R2, R3 would be the perpendicular distances. Okay, so this is perpendicular distance, this is the perpendicular distance, this is the perpendicular distance. So let's call this R1, let's call this R2, let's call this R3. So the moment of inertia would be m1 into R1 square plus m2 into R2 square plus m3 into R3 square, and so on. Is that correct? Simple. That is the most basic definition. Okay, but we are not going to deal a lot with discrete mass distribution. Why? Because now we are not in particle dynamics. Okay, now we are in rigid body dynamics. So when we are dealing with rigid body dynamics, we are dealing with objects which are extended. So where the force is acting is important now. Okay, so we have to deal with continuous mass distribution. Okay, so when we are dealing with continuous mass distribution, my formula or the expression for moment of inertia is going to come obviously in terms of integration, and that integration would be integral of r square dm. Okay, so what is dm? So what is the idea? The idea is to break the mass into smaller masses. Okay, very smaller masses, to break the mass into smaller masses. That will be dm. Okay, so you find dm, then you find what is the perpendicular distance of that small dm from the axis. Or what we can do is, so we talked about m1 r1, m2 r2, m3 r3, and so on. Okay, so what we can write is, what is the moment of inertia of particle 1? If I only ask about the moment of inertia of part 1, what will that be? m1 r1 square. Very good. If I only ask about the moment of inertia of the second particle, m2 r2 square, and similarly this would be m3 r3 square. So I can also write that the moment of inertia of the entire system would be summation of I small I. Can I write that? Obviously. Okay. So what I can do is, if I find the moment of inertia of different masses, I can just add up all those moment of inertia and I'll get the moment of inertia of the system. Is that correct? Okay. So what we can do is, if we break the masses into very small masses, if this comes out to be a point mass, then we can find the perpendicular distance, do the integral, find the answer. Or it may also happen that when we break these particles, or when we break a bigger mass into smaller masses, that small mass could also be a continuous mass. For example, let's say we are trying to break up a disk. Okay, let's say we are trying to break up a disk. Okay. So what is this disk made up of? Let's say I'm asking you to find the moment of inertia about this axis. Okay, so what is, if I have to break this disk into smaller shapes, what should I break it into? Rings, exactly. Okay, so we can break this up into smaller rings. So in this case, when we break this up, this small part, this dm, is also a continuous mass distribution. So I cannot define a single perpendicular distance for this object. Can I do that? I cannot. So this is a continuous mass distribution. So what we can do is, we can find the small moment of inertia of this small part, and then if we integrate that, we will get the total moment of inertia. Is that clear? Okay, so that is the idea behind finding the moment of inertia of continuous mass distribution. Is that clear? Any problem? Okay, now we are going to look at a lot of examples. Okay, so what I want to do is, obviously you have to remember moment of inertia of standard shapes, standard objects, plus I also want you to do a little bit of practice on integration. Is that correct? Okay, that will give you a little bit of more hold on integration. Clear? Can I rub this off? Okay, let's apply it. Probably we did it kabhi extra class mein na, we did it. Okay, anyway we are going to do it again. Okay, so the first thing you need to think about is a rod. Okay, kaisa rod? A uniform rod. Okay, so the most simplest shape would be a uniform rod. Okay, now if I ask you to find the moment of inertia of a rod which has a mass m and length l, how do you do it? Axis कौन पूछेगा? About what axis? That's the most fundamental question. Yeah, so ask. Nah. So if you ask about what axis, so now I'm telling you about an axis which is passing through the midpoint. Okay? So that becomes what? That becomes my origin. Okay? Then what I'm going to do? I'm going to break this up into small parts. So tell me what will be the representative element? Dx. More specifically, a small length. So when we choose a small length, if you remember, if we choose a small length or if we choose a representative element, we also find the position of the representative element. Okay, so what is the position of that representative element? X. Okay, so this representative element is at a distance x and it has a small length dx. Is that correct? Okay, next what do I need to find out? I need to find out the small mass, and that is dm. How do I find dm? Mass per unit length into the length. So the mass is m divided by capital L. That gives me mass per unit length into the length is equal to dx. Correct? Okay. Now what do I have to find out? I have to find out the small moment of inertia of the small particle. Okay, I'll call that what? I'll call that di. Okay. So this small element, what can I consider it to be? Can I consider it to be a point? ठीक है, because it is a thin line. तो thin line का कोई ये dimension तो है नहीं. If I'm taking this small part, this is almost like a point object. So for this point object, can I define a perpendicular distance? Obviously, what is that perpendicular distance? X. Excellent. So can I write that the small moment of inertia of the small element is equal to the mass? What is the mass? dm multiplied by what is the distance? X और उसका square. So this turns out to be what? This turns out to be m by L. Is that correct? हाँ. x plus dx मतलब क्या? नहीं. This dx is extremely small. This dx is extremely small. ठीक है. For example, now if I ask you what is the distance of your home to this institute, what is the distance? अरे किलोमीटर में बोलना. 1 किलोमीटर मान लिया. ठीक है. Okay. Now I ask you what is the distance between your home and this door? चल मान लिया 1 किलोमीटर. Now I'll ask you what is the distance between your home and this computer? कितना? 10 मीटर उसमें ऐड कर दे. So 1 किलोमीटर और 1 किलोमीटर 10 मीटर, how does it matter? 10 मीटर is very negligible compared to 1 मीटर. इसीलिए when we ask what is the distance of your home from this institute, you simply say 1 किलोमीटर. तो नहीं बोलता है कि नहीं फ्रंट डोर था 1 किलोमीटर 0 मीटर, आगे का डोर का 1 किलोमीटर 2 मीटर. You don't say that because it's negligible compared, right? तो वही फंडा है. So this dx does not matter if you take the length till here or you take the length till here. It does not matter. Is that clear? Okay. So we say that this entire element is at a distance of x. Clear? That is the fundamental idea behind integration. ठीक? m by L x square dx. हो गया? Now all we need to do is what? Integrate. So if we integrate, we are going to get m by L will come out. अंदर बचेगा x square dx. Now very carefully tell me what will be the limit of integration. Very good. Minus L by 2 to L by 2. Because you have chosen the origin at the center. So if you go along this, that will be positive. So when you reach this point, you get L by 2. When you reach this point, you get minus L by 2. So you have to cover from minus L by 2 to L by 2. Is that correct? So this becomes minus L by 2, say L by 2. Okay. X square ka integral. Thank God. Okay, x cube by 3 will put the limits, and that will be what? That will be directly लिख देते हैं. So this will be this. So this will come out to be ml square by 12. ठीक है? Is that clear? Okay. You put the limit, you'll get this. Okay, don't worry about this. Okay, so this comes out to be ml square upon 12. Okay, so this is a result you have to remember. Okay, what you have to remember? That for a uniform rod, first thing, a uniform rod, about which axis? About the axis passing through the center, the moment of inertia is ml square upon 12. Is that clear? Any problem? Can I rub this off? Suppose we get a non-uniform rod. Take it. Non-uniform means what? Non-uniform means what? The density. Density, when we are talking about a linear object, we are talking about the linear mass density. Matlab mass per unit length. Correct? Okay. So this could vary in any form. This could vary in any form. So I'm taking a simple example. I'm saying alpha x plus beta. चलो मान लेते हैं that the density is varying as alpha x plus beta, where alpha beta are constant and x is the distance from the left end. Okay, that is given to you. The density is varying like this. So what we need to do is we need to find out the moment of inertia. Okay, how will we find out the moment of inertia? What is the axis? ठीक है, चलो axis बार change कर देते हैं. The axis is this end. ठीक है, the axis is this end itself. So x is the distance from this end. Okay, so we'll choose this end as the origin. Okay, so what is it that we have to do? एक बार करो, करके एक बार try करो and tell me the answer. I should also give you the length of the rod. The length of the rod is L. That I have to give you. Yeah, the length of the rod is L. देखा? ठीक है. I'm not checking the calculation, but what you've done is correct. ठीक है. Okay, good. Again, there is no debate about the representative element. ठीक है, the representative element would be a small length dx at a distance x from the axis. Okay. Now what do we have to find out? We have to find out dm. What is dm? So people who remember dm as m by l into dx वो हमेशा गलती करेंगे because यहाँ तो m है ही नहीं. Its density into the length, basically mass per unit length into the length. That is the length of, that is the mass of the small element. Okay. If you have a surface, then how would you find dm? Mass per unit area into the area. If it is a volume, mass per unit volume into the volume. That's how you do it. Correct? Okay. So what is mass per unit length? Mass per unit length is given to me. That is alpha x plus beta. Okay. What is the length? The length is dx. So this becomes dm. Okay. What is the distance of dm from the axis? It's x. So di will become what? Di will become dm into x square. So this becomes, is that correct? Okay. And then the moment of inertia will then become the integral of, और इसको अंदर ले जाओ, so this will become easy, alpha x cube plus beta x square dx, and the limit of integration is going to go from 0 to capital L. ठीक है, तो यहाँ से what would I get? I'll get alpha L to the power 4 by 4 plus beta into L cube by 3. That's it. Clear? Any problem? ठीक है. Now this function could be anything. This function could be anything. कुछ भी दे सकता है. Is that clear? So depending on that function, you'll have to calculate dm. ठीक है, that's your job. Clear? Any problem? Can you rub this off? Next is a ring. Okay, so this ring has a mass m and a radius r. ठीक है, इसका moment of inertia कैसे निकालेंगे? How do you find the moment of inertia? ठीक है, एक्सिस कौन पूछेगा? Oh, तो तुम समझ गया. ठीक है, it's all right, it's all right. Okay, so the axis is, listen carefully, the axis is, how do you define this axis? Or how do you describe this axis? Correct. So axis is passing through the center and perpendicular to the plane of the ring. ऐसा ही लिखा रहेगा. Alright, if they're talking about this axis, so how do you describe this axis? It is passing through the center and perpendicular to the plane of the ring. Okay, so what will be your representative element? What will be your representative element? Small? Small what? Small arcs. ठीक है, small arcs. So if you take a small arc, ठीक है, and you join all these arcs end to end, ठीक है, if you join all the arcs end to end, you'll get the entire arc. ठीक है, so what is that? That is, so this small arc will become what? This will become dm. Is that correct? Okay, so once we have chosen the representative element, we also have to choose the position. ठीक है, what is its position? Its position is r from the axis. Is that correct? क्या हो गया? So this position is r from the axis. Correct? Okay. So इस छोटे से element का, first of all we need to find out dm. So tell me what dm would be. Mass by area. Mass by circumference. Again, so first of all you have to decide, is it a linear object, is it a surface, or is it a volume? Okay, so what is this? It is a linear object. Matlab the mass is distributed along the rim. There is no mass, there isn't mass anywhere else. Okay, so the mass is distributed along the rim. So what is this? This is a linear mass distribution. Okay, if this is a linear mass distribution, we find dm as mass per unit length into the length. Okay, so what is the mass? Mass is m. What is the length? What is the circumference? The circumference is 2 pi r. Then into what? Into d theta nahi hoga. We have not chosen theta. I'll tell you why we have not chosen theta, but ठीक है. But नहीं, इसमें ये भी करने की ज़रूरत नहीं है. इसमें ये भी करने की ज़रूरत नहीं है. और चलो कर लो. ठीक है, तुम्हारी मन की शांति के लिए कर लेते हैं. ठीक है ठीक है ठीक है, विल डू दैट, विल डू इट इन दैट वे, देन विल डू इट इन अ सिंपलर वे. ठीक है, कर लेते हैं. That'll tell you a general method. That will tell you a general method. Okay. So in case of rings, how do we choose an element? We go to angle theta. We have done all of this. याद करो, potential energy में, center of mass में, we have done everything. ठीक है. So at an angle theta, we take a small element, मतलब we go a further angle d theta. ठीक है. Then we choose the element which is intercepted or which subtends an angle d theta at the center. Okay. What is the length or what is the radius? R is the radius. Okay. Now tell me, what is the length of this arc? R d theta. Very good. The length of this arc is R d theta. Take any problem? Okay. Now we can find dm. So what is dm? dm is mass per unit length. So mass upon 2 pi r multiplied by what? Multiplied by r d theta. So this gives me m upon 2 pi into d theta. Any problem? Okay. Now tell me, what is the distance of this dm from the axis r? Okay. So what will be the moment of inertia of this small element? Now hold on. This small element, what would you consider it to be? What would you consider it to be? A point mass. Okay, you will consider it to be a point mass. Okay. So how would you find the moment of inertia? The mass multiplied by the distance, the perpendicular distance from the axis. So what is the perpendicular distance from the axis? कहाँ से r sin theta? This is the axis. The axis is like this, right? So what is the perpendicular distance from the axis? It's only r. Correct? Any problem? Okay. So this becomes dm, and what is dm? dm is m upon 2 pi into d theta multiplied by what? Multiplied by r square. So to find I, we have to integrate this. So first of all, take out all the things which are constant. What are the things which are constant? M is constant, 2 pi is constant, r square is also constant. For all the element, what will be the distance from the center? R. So r square is also constant. We take that out. तो अंदर क्या बचा? अंदर बचा d theta. Now tell me, what will be the limit of integration? Very good. The limit of integration would be, you have to cover the entire ring. So you start from here, angle 0, the angle increases, and then you reach this point. So what will be that angle? 2 pi. So you have to go from 0 to 2 pi. Okay, so this becomes mr square upon 2 pi. इसका d theta का integral will be theta. Put the limit, you will get 2 pi. तो बचा कितना? mr square. And this is also a result you have to remember. ठीक है? The moment of inertia of a ring, again uniform ring. ठीक है? The moment of inertia of a uniform ring about an axis passing through the center and perpendicular to the plane of the circle is mr square. Is that correct? So this is the proper way of integration you have to employ. Okay, यहाँ से क्या सीखने को मिला? What did you learn from here? कुछ सीखा? mr square तो रट भी लेगा तो काम चल जाएगा. सीखा क्या? इंटीग्रेशन तो सीख चुका है. d थीटा का इंटीग्रल थीटा होता है. सीखा क्या? Specifically what about applying? नहीं, ये easier way थोड़ी था. This is the standard way of applying. What specifically did you learn about this method? But the most critical part is choosing an element, choosing the representative element. If you choose the representative element, 80% of your job is done. बाकी बस mathematics है. दिमाग किसमें लग रहा है? नहीं, I'm not saying कि mathematics में दिमाग नहीं लगेगा, but this form of mathematics is very trivial. This is unitary method, and then integration का एक formula. That's it. The mathematical part here is very trivial. What is the important part? How to choose the representative element. If you choose that correctly, 80% of the job is done. So what did you learn here? In an arc, how would you choose a representative element? You have learned that. तो अगर इसके बजाय if even instead of calculating moment of inertia, if this were a charged ring, तो पूछेगा इलेक्ट्रिक फील्ड निकालो, पोटेंशियल निकालो. अगेन द मेथड टू चूज द रिप्रेजेंटेटिव एलिमेंट वुड स्टिल बी द सेम. इज दैट करेक्ट? सो नाउ दैट यू नो हाउ टू हैंडल द रिंग, ठीक है, you can apply it anywhere. So the important part is how to choose a representative element for a ring. Is that clear? Now you have learned that. Okay, you'll choose an arc, and how will you choose that arc? You'll choose the angular position to be theta, and the ring or the arc has to subtend an angle d theta at the center. Is that clear? ठीक है, this is the learning you need to extract. बाकी तो रट के भी काम चल जाएगा. Clear? Can I rub this off? Again, this was a result for uniform ring. ठीक है. Now we can talk about a uniform disk. ठीक है, पहले से axis बता दे रहे हैं. This is the axis. Okay, so this uniform disk has a mass m and radius r. ठीक है. Okay, now tell me how do you choose a representative element? Concentric ring. ठीक है, concentric ring. How would you choose that? You will choose a ring, but what position you will assign? What will you assign to it? Distance from the center, and then ठीक से बोलना. अरे रुक जा, इंटीग्रेट बाद में. Radius of x and thickness of dx, correct. That is the way you are going to choose. So you will go to a distance x, form a ring. ठीक है, you will go to a distance x, then form a ring. Now what you will do is, you will go a further distance dx, you will go a further distance dx, and then again form a ring. So this small distance is dx. ठीक है, so what is the ring we are talking about? We are talking about a thin ring. We are talking about a thin ring which has a radius of x and which has a thickness of dx. Is that correct? Okay, very good. So previous to disk, what we have seen? We have seen a ring. So we know the formula for the moment of inertia of a ring. Don't we know that? We know that. So all we need to do is find the mass of the ring, find its small moment of inertia using mr square. We know that already, and then integrate that. That's it. Okay, so what is the difficult part? The difficult part is done. So how do we proceed? What is the first thing we need to find out? dm. We need to find out dm. Okay, अब इसका dm मेरे को बताओ. Mass per unit area into the area. Okay, mass per unit area. Mass per unit area into the area. Area क्या होगा? 2 pi r dx. 2 pi r नहीं, r नहीं, 2 pi x dx. अब याद आया. हमेशा तुम लोग की आदत है, मतलब अच्छी बात हमेशा एंड में कहते हो. ओके, डोंट यू रिमेंबर. क्या हो गया? क्या चॉकलेट लाया हमारे लिए? अच्छा, किताब लाया है. लगा बर्थडे